आपण एखाद्या ऑर्गॅनिक कंपाऊंडचा अभ्यास करतो त्यावेळेला आपण ऑर्गॅनिक कंपाऊंडची डेफिनेशन, त्याचं नॉमेनक्लेचर, त्याचं क्लासिफिकेशन, त्याचं प्रिपरेशन, त्यानंतर येतात त्याच्या फिजिकल प्रॉपर्टीज आणि त्यानंतर केमिकल प्रॉपर्टीज. विथ द सिक्वेन्स ऑफ व्ह्यू आपण आज केमिकल प्रॉपर्टीज बद्दल अभ्यास करणार आहोत की त्या केमिकल प्रॉपर्टीज मध्ये तो वेगवेगळ्या अदर रिएक्टंट सोबत कशा पद्धतीच्या रिएक्शन देतो, हाउ इट रिएक्ट्स विथ द अनदर ऑर्गॅनिक कंपाउंड्स and what types of the compounds are produced during the chemical reaction. During this, the most important reaction for today's discussion is acetylation. The name acetylation, also known as acetylation, somewhat a simple single difference is there, acetylation between and acetylation. The acetylation word comes from the word acetyl. प्रोनाउन्सिएशनचा वापर करत असताना ॲसिटाइल आणि ॲसिटिल असे ग्रुप आपण करत असतो. हा जो ग्रुप आहे CH3 C डबल बॉन्ड O आणि हा डॅश, दिस ग्रुप इज नोन एज द ॲसिटिल ग्रुप. आणि द रिएक्शन वी डिफाइन द acetylation, the reaction in which one or more hydrogen of the organic compound is replaced by the acetyl, that is CH3 C double bond O group, is known as acetylation reaction. We have to first define what is acetylation. After that, the acetylation reaction is most important for the organic compounds. For the amines, there are, according to the classification, there are the three types of amines: primary, secondary and tertiary. This method is useful for distinguish the amines. How it is possible? As primary amines, secondary amines and tertiary amines differently reacts. They form the different products. They react with a different way or method. Since this reaction is used for the identification, detection of the primary, secondary and tertiary amines. Now, before we are going towards the reaction, now first of all, acetylation is used for using the acetylating agents. And the most important acetylic agent is acetyl chloride. This acetyl chloride is having the formula CH3 C double bond O Cl. This is the acetyl chloride. Second one is the acetic anhydride. Acetic anhydride. Now we are discussing the points which are according to the objective purpose, according to the neat corner, CT corner. This is not the actually acetylation, but this is the generation, how the acetyl group generates from the organic compound, and thus the acetyl chloride or acetic anhydride. If you observe that in these two compounds, the acetyl or acetic group is one. Now, whenever we go to the back of the history, we shows that these are the derivatives of acetic acid, which has the source, that is the vinegar is the source. 6 to 10% acetic vinegar is having the acetic acid, and this acetic acid, by the action of either PCl3, PCl5, SOCl2 or concentrated HCl in presence of anhydrous Cl2, we are able to prepare acetyl chloride from acetic acid. Nucleophilic substitution reaction, where the OH, that is the hydroxy group, is replaced by the Cl, that is the chlorine, and thus acetic acid is the most important part for the preparation of the acetyl chloride. Then second one is the acetic anhydride. Two molecules of the acetic acid are condensed. Condensation is the process in which the byproduct are either water, either alcohol or alkyl halide. This type of the reaction is known as condensation. Now in this condensation we have to heat this product, and whenever we heat, there is a removal of water. The removal of water is also known as a dehydration. Concentrated HCl, concentrated H2SO4, anhydrous Cl2, these are generally used as a dehydrating agent. But for this purpose, a different type of the dehydrating agent, which is the P2O5. In inorganic chemistry, for the periodic table, in the 15th group, nitrogen, phosphorus, arsenic, antimony, bismuth, in which the phosphorus is having the oxides along with these oxides can also be written as a P4O10. For the stability of for the sake of convenience, we are using the P2O5 as a oxide of the phosphorus. Now, this P2O5 acts as a dehydrating agent where the H from one acid and OH from the another acid goes and there is a removal of the H2O to form the acetic anhydride. Acetic acid, which is also known as the ethanoic acid. This is known as ethanoic anhydride. This is the anhydride. The product formed by the removal of the water is known as anhydride cis. In this reaction, there is a removal of water. This reaction, acetic acid, ethanoic acid, acetyl chloride, ethanoic chloride. Now, these are the two reactants used for the acetylation. We are having the amines are among the organic compounds having the hydrogens. We define acetylation as the reaction in which the hydrogen of any organic compound replaced by the acetyl group CH3C double bond O is known as acetylation. Now, for this reaction, what is the catalyst? Catalyst plays the most important role for this reaction. And for the catalyst, the chemical substance which increases or maybe decreases the rate of reaction is known as a catalyst. Now, this reaction, according to the pronunciation, we call either as a pyridine or pyridine. This pyridine, N, this one is the structure of the pyridine, C5, H5, N. This is the structure of the pyridine, and if we observe that this is the benzene having the unsaturation, that is the presence of the double bond, these 6 carbons having occupying the hexagonal structure and each having the hydrogen C6H6. This is the formula of the benzene. Now, one hydrogen and one carbon removed from the benzene and it gets pyridine. What is the difference between these two compounds? This is a homocyclic compound as the ring is formed by the same carbon atom, but it is a heterocyclic compound. This ring is formed by the 5 carbons and 1 nitrogen. Hence, it is a heterocyclic compound. This pyridine, why pyridine is used in this reaction? Before we have going to the reaction, in the acetylation reaction, if we use the acetyl chloride, hydrogen of the organic compound is removed, so H and Cl, HCl is the byproduct. If we use the acetic anhydride, this, that is the CH3C double bond OH is the byproduct. If you observe that this is the hydrochloric acid, while this is the acetic acid, both are the acids, and if the byproduct is acidic, then it affects on the product, and hence we have to neutralize these byproducts, that is the acidic nature compound. So, what is the nature of pyridine? Pyridine is having the lone pair of electron, and in the earlier periods we discussed that in 1923 Gilbert Lewis, that is the Jean Lewis, defined that the electron pair donors are the bases while electron pair acceptors are the acids. Then nitrogen having the lone pair of electron, it is ability having the tendency to donate the pair of electron, hence pyridine is a base. Now we have to neutralize the byproducts, and so base is used for the neutralization reaction. Today's this discussion, what discussion? Before acetylation reaction starts, we are going to discuss the previous part, how acetylation can occur in the chemical reaction using acetyl chloride or acetic anhydride. Now, we are going to, for the actual reaction, amines are the organic compounds. Now, in this reaction, we have to give the acetylation of the amines. Now, for acetylation reaction, we are using the agents, and acetylation reaction is the reaction in which primary, secondary and tertiary amines are used. This is the introduction to the acetylation. Now in the next section we are actually giving to the acetylation of the amines.